Hello, my name is James King and I'm a digital product designer from London. I'm the founder and owner of a company called Science Practice, and I'm also the co-founder and part owner of another company called Control Group. I won't get into what these two businesses both do, but for the purposes of this talk, it's useful for you to know that both businesses have been running for about 10 years, and both are small businesses with about 5 to 10 employees each. I discovered Ergodicity Economics about 2 years ago and have been following the community closely since then. My entry point was Ollie Peters's coin toss gamble, followed by Mark Ellsberg's Farmer's Fable, which is where it really clicked. And I also own a really well-thumbed copy of Fortune's Formula by William Poundstone. These ideas really shifted my worldview. However, I'm not an economist or a researcher, and I don't work in insurance or finance. So it took me a while to work out where I might be able to apply these ideas. I'm sure that people might recognize this image from Ollie Peters and Alex Adamu's paper, The Ergodicity Solution to the Cooperation Puzzle. When I read the paper, I felt a very strong parallel between it and the history of my two companies. Over the lifetime of these two companies, there have been moments where one has been doing better than the other, and during these times, it's been very useful to share resources between the two companies in the form of money and people. Some of my team have moved between these two companies, sometimes splitting their time and sometimes swapping between them. It's been useful to move cash back and forth between them if one required money to cover cash flow. I can think of numerous times where either business might have failed without the support of the other. And while I'm really proud of keeping these two businesses going for about 10 years, I would like to see them grow a bit faster. And one way to boost growth could be to cooperatively pool and share wealth with larger groups of businesses like mine. So that's what this talk is about. How can I put together a group of businesses like mine that pool and share their wealth and grow faster together as a result? For the rest of this talk, I'm going to focus on science practice just to keep things simple. And I'm going to try and answer these three questions. The first is whether science practice is the type of company that would actually benefit from pooling and sharing. The second question I need to answer is what sort of other businesses would it be mutually beneficial to pool and share with? And the third question is how to actually start and organize a cooperative pooling and sharing scheme. So let's start with the first question. Is science practice a company that could benefit from pooling and sharing? After all, we're not a farming company, but we do need to understand whether there's a multiplicative dynamic to our business. So now I better explain a little bit about how our business works. Science practice is a consultancy made up of a team of researchers and designers. The team works on projects for our clients. Like most businesses, we use a quarterly accounting period. And at the beginning of each quarter, science practice starts with a certain amount of money in the bank. Let's call this our starting wealth, or W0. This starting wealth is divided into two parts. There's the part we invest in winning and delivering projects during the quarter. This is the same thing as our quarterly costs. The second part we don't spend and we keep in the bank for the duration of the quarter. We can define a value P, which is the proportion of the starting wealth that we'll spend. A P of 0.5 means that we'll invest half our wealth during the quarter. A P larger than 0.5 means that we'll invest more than half our wealth. And a P lower means that we'll invest less than half our wealth. During the quarter, the money that we invest will hopefully bring a return. The size of the return will depend on how lucrative the contracts we win are and how efficiently we use our time to deliver the projects. Again, we can define another value, R, to represent the return on the wealth that we invested. An R with a value greater than 1 means that we made a positive return on the money that we invested. But if R is less than 1, then we'll have made a loss. At the end of the quarter, we have an ending wealth that's made up of the wealth that we invested, including any returns, plus the money that we retained in the bank. Let's call this W1. This W1 then becomes the starting wealth for the next quarter, and the cycle begins again. So what does growth look like if we choose values of P set to 0.5 and R set to 1.3 and keep these constant over 12 quarters or 3 years? Well, we see a nice exponential increase in our starting wealth. No surprises there. But unfortunately, we don't get to choose a fixed value of P and R. It would be nice if we could. Instead, P and R vary from quarter to quarter depending on the many unpredictable factors that contribute to the success of our business. We could simulate a time series with a random value of P and R, but let's use real data instead. These are the real numbers taken from science practices accounts over a 3-year period. And when we plot the resulting change in wealth over time, the first thing to notice is that we don't see a nice exponential increase in wealth as before. Instead, it's more or less break even. I have to confess that science practice is not the sort of business that gets venture capitalists particularly excited. But let's see if pooling and sharing could reveal some hidden potential for growth. And to model this, I'll create several variants of science practice. These variants exist in a parallel universe and experience changes in their wealth independently of one another. Each variant has been created by taking the same set of real numbers from science practices accounts, and then we shuffle the values of P and R randomly, so that the variant experiences an identical set of quarterly returns to the real science practice, but in a different order. We can then shuffle again, and again, and again, until we have 10 versions of science practice, the original and 9 variants. Each of these variants all start and end with identical values in wealth, but each one has its own independent trajectory. Now, if all of these variants pool and share their collective wealth on a quarterly basis, then each variant, including the one in our universe, would follow this trajectory. And compared to the real figures, fluctuations are reduced, and we can see that the pooling and sharing has conferred a growth benefit. This trajectory is approximating an exponential curve with a fixed p of 0.5 and an r of 1.08. And admittedly, this is still a modest growth rate, but over the longer term, even small rates of exponential growth have powerful effects. And what's more, this growth doesn't rely on working harder or being any luckier. So I think I can answer yes to my first question. Science practice could benefit from pooling and sharing with other companies. So moving on to my second question, what types of companies would it make sense to pool with? I don't have any concrete answers to this question yet, so my answer is fairly speculative. As Ollie Peters reminds us, it's sadly not possible to cooperate with variants in parallel universes, so I need a way of assessing other real businesses for their pooling potential with mine. And here are a list of factors that I think will be important to consider. The first set of factors relate to the business model of the company. The other company's business model needs to be relatable to me. I need to be able to understand it. The other business also needs to be broadly aligned with my own. It would be a problem to pool with another company that I felt had an exploitative or unethical business model. And lastly, it's probably not a good idea to pool with a business if their growth would be at the expense of my own. The next set of factors relate to the financial model of the business. This needs to be compatible with mine. This probably means that it should have a similar dynamic over a similar time frame. A venture-backed startup has a very different financial model to a consultancy like Science Practice and probably wouldn't be compatible. And lastly, the financial model needs to be uncorrelated, otherwise pooling won't confer a growth benefit. So on to the last question of this talk. What is the best organizational structure for a pool? When I first started researching this talk, I assumed the answer to this question would be to form some sort of cooperative. But there are other types of organization that enable their members to pool and share their resources. Right now, I don't have a clear idea of which one is the best, but I'll present some examples. So let's start with co-ops. Co-ops come in many different shapes and sizes, and to cut a long story short, the type of cooperative that probably fits best is what's called an inter-cooperative consortium. A good example of a cooperative consortium is the Mondragon Corporation based in Spain. This is a very large consortium, about 100 individual cooperative businesses, and collectively they've got the scale of a multinational corporation. Another organizational structure is a conglomerate, a good example being General Motors, especially circa the 1930s when Alfred P. Sloan was in charge. Each division of GM is a car company such as Chrysler, Chevrolet, or Oldsmobile, and each is operated with its own brand, product line, and dealerships. Alfred P. Sloan wrote a great book about how these divisions were organized, balancing out the need for central coordination and decentralized management. Another model I really like is a partnership. A good example is Pentagram, a design consultancy formed by a team of partners. Each partner runs their own practice, hires their own team, chooses their own clients, but all revenue is pooled and shared between these different partner practices. And lastly, we have career risk pools. This is a name I made up to describe a company called Pando. Pando organizes pools of people who are in the early stages of a high-risk, high-reward career, such as professional baseball players or entrepreneurs. The members of these pools make an agreement that if one member of the pool beats the odds and makes it, then they'll contribute a small percentage of their earnings to the pool for the rest of their career to be shared equally with the other members. Thank you to Athena for mentioning this one to me. So that brings me to the end of my talk. I would really appreciate any feedback from the Ergodicity Economics community, especially if you spot an error in my reasoning or models. Maybe you know of a business that might make a good member of a pool with science practice, and perhaps I'll be able to report back next year's conference with an update on how it's all going. But for now, I'd just like to thank Veronica Poor for her feedback over the last year, and to Ollie, Benjamin, and Colin for the opportunity to talk here. And I'd like to thank you for listening. Bye.